Good morning, seventh graders. Happy rainy day. We've been looking at the weather like crazy, as even as I start my videos in the morning. So just a quick Friday video with a little bit of instruction, no assignment, as promised this week. Nothing to have to accomplish or turn in. Just pay attention, continue to learn, and if you don't have your work done, that would be the biggest message, that I cannot provide feedback with the sheets that you're going to get in the mail. And it's just brief snippets, but I can't give you anything if you don't do your work. Okay, so the image you're looking at, and I'm going to switch to just full view here. Whoops, not that one. All right, the image you're looking at should be, it's really weird. All right, it should be this deal here. So I had a question come up that asked, what, the sun's energy, when it comes to the earth, do we get all of the sun's energy, and does all of the sun's energy get absorbed by our planet? And the best answer would be, thank goodness no, because if it did, we wouldn't even exist. One, it's too much energy for the planet to absorb, and too much energy for a human being to be out in. If our atmosphere did not get rid of much of the energy, we just simply wouldn't have the planet we have, and we wouldn't exist. Including a lot of the really harmful stuff like the gamma energy and high concentration of, UV and X-ray, stuff like that. So if you look, you can see here that 6% of it is scattered from the atmosphere. Fortunately, way up high in the atmosphere is where the gamma radiation is bounced off, so that's good. 20% scattered and reflected by clouds. The clouds absorb about 19%. About half of it is absorbed by the earth, and then about 4% is reflected, so it just bounces off and isn't absorbed. And of course that probably happens frequently in smoother, shinier surfaces like water. So point one, not all the energy that comes from the sun is absorbed by the earth's surface, or we would be in trouble. So the atmosphere does a great deal, and you're old enough to have heard a lot of things about us having to take good care of the atmosphere by not continuing to put carbon fuel emissions into the atmosphere and subsequently damaging it. They call it a hole in the ozone. Is a gas that's really good at blocking gamma energy, and they called at one point, they said there was a hole in the ozone layer. Now it can repair itself and has quite a bit, but a hole in the ozone layer would let more energy into the atmosphere and subsequently warm up the earth more. Okay, so here's a really great diagram I found that takes you through energy transfer. Solar energy reaches the earth. This is radiation. It's absorbed by the earth. And then obviously, and if you look at the molecules here compared to the molecules here, this is less dense, warmer air. And so, of course, less dense, warmer air will move up. Now, this is a collection of air. So that energy, that collection of air, now here we have, remember when the surface heats, those molecules of the ground and the grass and so forth collide with the molecules of the air above it and make it vibrate. And they transfer that thermal energy and make that mass of air warmer. So now it's warmer and less dense. It'll go up. This is now convection because you have an air mass, fluid mass, moving energy with it. Then eventually it'll cool. As it cools, it'll move off. And as it cools, it becomes more dense and it's going to come down. So less dense up, more dense down. And this cycle, and this is just one small little picture of a tiny chunk of the atmosphere. You can imagine all the variations and all the differences that happen throughout the entire surface of the earth with, you have water and mountains and snow and all sorts of things. So it doesn't happen equally, and that's how we end up with weather, because of that unequal stuff. Okay, One more. So here's a basic. Sun heats the ground, right? Ground heats the air. Air rises. Now remember, when this warm air rises, it's not going to leave an empty space underneath or we'd be in trouble again. We wouldn't be able to breathe. So cold air is going to move in and replace it. And that cold air, when it moves in to replace it, that creates wind. All right? I wanted to show you this one because this always reminds me of some. Here's a hot road, and you've seen above the hot road. There's cold air over the grassier areas, but that hot road, boy, always looks wavy above. So airplanes actually have to really watch out for this on really hot days because that less dense, rising, warm air. Remember, airplanes, they need to land. So one, if you have a lot of warm air rising above the blacktop on a runway, it's really difficult for airplanes to land. That rising air gives them more lift, and it's hard for them to get that airplane down. The other thing is if the airplane is trying to take off, and you have this, airplanes will want to lift off the ground before they're ready to, and that can cause a problem too. So pilots are very well aware that they have to land very carefully, and you have to take off very carefully. On hot summer days when I was learning how to fly, we had to hold the airplane onto the blacktop and push forward on the control and hold it on the blacktop just a little bit longer to be sure that we weren't getting this premature lift from warm air. Okay, so just more and more about energy transfer through the atmosphere. Hope that makes sense. Have a good Friday. It's supposed to clear up and get sunnier. It's your last Friday of the school year. If you got your work done, great. Enjoy the video. Post a thumbs up in the comments so I know you're all doing well. And if you did not get your work done or haven't, I would suggest starting to get some done as I progress through these reports for you. Otherwise, send me any questions if you have any. Don't forget, next week is the Wolf Crawl, where we'll be lining up and driving by to wave hello and happy summer to you. It'd be great to see your faces one more time before we sign off of distance online learning and before we head off for the summer. All right. Thanks, guys.